But with that, I'd like to start introducing to you, Swagger and some tooling that supports ABL developers in utilizing Swagger to make the consumption and building of REST and HTTP-based APIs easier, tooling part of the SmartComponent Library. So let me briefly introduce myself. I'm Mike Fechner. I'm the director of Consulting Werk, also the founder of Consulting Werk, but I'm also involved in the technical side of the business. I'm responsible for the development of our tools like the SmartComponent Library, but also work intensively together with our customers, where I usually support them as an architect in modernization related questions. I'm using OpenAPI for Progress now for way over 30 years, starting with version 5. And well, ever since Progress has provided the object-oriented capabilities in language, I started using that as my preferred programming style. Well, I try to keep active in the OpenAPI community, well, as an attendee of conferences, but also frequent speaker. Well, what we do at Consulting Werk, we support organizations that develop in OpenAPI. The development side of OpenAPI is really our main focus area. We can also help customers bringing applications into production environments. But we tend to focus on the development side of things. We deal with OpenAPI and related technology, front-end technologies like .NET, Angular, other technologies that makes sense to be used together with OpenAPI. We're a team of 17 people all over Europe and the United States. Our main office is in Cologne in Germany. And from there, we're working together with customers, almost all over Europe, Northern America, Australia, and Southern Africa. We're providing consulting services, but also developer tools like the SmartComponent Library. And in this webinar, I'm going to introduce a few of the aspects of the SmartComponent Library. And generally, we use our capabilities in modernization projects around OpenAPI. Good. So let's talk about Swagger. When we support our customers during integration projects, nowadays the question typically is, well, where's the Swagger file? Where's the Swagger file describing the APIs that we need to talk to, or the endpoints provided by an application that we need to talk to? Or what are the endpoints that we need to provide in order to be accessible by another application? Swagger is generally used to describe HTTP-based APIs, and more HTTP-based APIs are used. Likewise, Swagger is typically used to describe JSON messages, but can also describe XML messages in the same way. We had integration projects where a third-party application provided a Swagger file and said, well, if your bespoke ERP system is implementing the Swagger file, then our warehouse management system knows immediately how to interact with your ERP system. And for the other direction, the standard WMS system may provide a Swagger file with the endpoints that it provides for the internal ERP system. And Swagger does not only allow you to describe APIs, it also makes it easy for developers to test those APIs and make sample requests and get first experience about what data needs to be provided. So it's a tool to document REST and RESTful APIs. To a degree, it brings the description of endpoints and data formats schema back to RESTful APIs that got lost when moving away from SOAP. SOAP, there's always the WSDL or the WSDL document, and Swagger brings a lot of this description to the REST world, to the JSON world. Simplifying tests, it's easier to use than tools like Postman, and it saves the developer from having to build a client application. Swagger is a widely accepted standard, so when you have more advanced use cases for testing APIs, maybe testing a sequence of calls, then Swagger files can be imported into Postman and other tools. And that's really an interesting aspect of Swagger. Swagger is designed to support the generation of either API clients or service stubs. Service stubs is you build whatever in whatever technology that you need to implement your service in. You build basically an empty method with the correct set of parameters and additional descriptions, so that you can immediately focus on implementing the business logic and the data access logic within such a service stub, and you don't have to deal with fiddling around with generating the correct interface, so the correct parameter types, the correct HTTP methods, etc., etc. So within the SmartComponent Library, we do have a lot of support for REST and RESTful. REST has become the standard protocol both for application integration and to provide UI flexibility. Typically, modern browser-based front ends use REST or RESTful interfaces to talk to an application backend. We are convinced that within the SmartComponent Library, we provide both the simplest and most flexible method to implement REST and RESTful services with OpenEdge. And yeah, the use cases that our customers have there are either implementing new functionality as RESTful services or provide existing legacy functionality in an OpenEdge-based application as a RESTful service. Since quite a while, we do provide an OpenAPI or Swagger documentation out of the box as soon as you expose any functionality as REST within the SmartComponent Library. We build the Swagger documentation out of the box on the fly as soon as you are able to execute the request within your PaaS. For us, in the SmartComponent Library, the deployment efforts for deploying RESTful services are much simpler with the REST service that Progress provides out of the box. We don't need to build an REST package, a WAR or PAR file, and deploy that to PaaS and yeah, cross fingers that it actually all works out. We just deploy R code and description files into a production environment, and immediately the API is provided based on that. And we also support quite a range of authentication and authorization features, either part of PaaS configuration or as functionality within the framework. So recently we've ensured that we support all the aspects of OpenAPI 3.0, which is actually the latest specification for Swagger documents. And we have now aspects, and that's what I'm going to show you later in this presentation, of an API first design, where following an API description in a Swagger file, we can start generating services that implement this. We can generate ABL clients for existing REST services. When we start working with new customers, there's usually some concern whether all our nice and modern features, which are all based on object-oriented code, whether they have problems with the dirty side of ABL legacy programming, like shared variables or global shared variables. And we do have solutions for all that. We can, at the beginning of a request, make sure that the user and login company and other shared variables are initialized based on the session context, so that when business logic ultimately executes maybe a database trigger that needs access to a shared variable, that those are accessible and populated with the correct values. So let's look a bit more structured on Swagger or OpenAPI. OpenAPI and Swagger are two terms which some people use as synonyms for each other. OpenAPI is a specification that describes how REST services can be documented, and Swagger is actually a suite of tools around that specification. That's at least the status now. Swagger and OpenAPI is supported by the OpenAPI initiative, which is a initiative supported by major IT companies like Atlassian, Google, SAP, PayPal, IBM, it's generally a standard for describing synchronous HTTP APIs. So Swagger is a collection of tools supporting the work with those OpenAPI specs. There are tools to edit Swagger documents, the API specifications. There are tools to generate code either for clients or services. There's the Swagger UI, which probably most people have seen already, which provides online documentation and the ability to test the services. There's Swagger Hub and Swagger Inspector, so more tools for providing API descriptions, so working in a team and testing them. When you look at the Swagger website, you will find there an example, the Pet Store, which is a collection of endpoints that, the story behind it would be like a pet store where you can look for pets which are for sale or which are in the store. You can get details about them. You can edit them to the backend for a website running a pet store or something like that. I'm having a sample client that I will show you later. I'm not yet quite sure whether it will actually work, because in the last couple of days, I experienced that the Swagger backend of that demo application wasn't always working. So let's see if it actually works when we get there. But I think whether or not we get an actual result isn't the key. It's more like how we would be getting there when the service is operating. For one of the methods, so this is the method to find pets in the store by the status, and the status could be, that's what you see there in the dropdown, either available, pending, or sold. You could run a query against the backend of that store, and then you get a response with a list of animals or pets that are available in that status. And all this page is dynamically generated from the Swagger files. So the text there about status values that need to be considered for filter, that available, pending, sold, etc. are possible options. All this is part of the API specification. And also what you see then at the bottom, the schema of the expected response is also part of the description. One other use case for Swagger that many OpenEdge users have probably seen already is the OE Manager, the OpenEdge Manager. OE Manager is a management interface for PaaS-OE. Once you deploy the OE Manager web application into PaaS-OE, PaaS-OE provides RESTful endpoints to query the status of it, to get details about statistics, number of requests, number of users, number of sessions, etc. But it also allows to issue maintenance comments like trimming an agent, so a controlled way to shut down one of the agent processes in PaaS-OE. All that is available as a REST service, and Progress has provided a Swagger page to describe that. So when you have a PaaS-OE running, and you go to the /OE Manager /endpoint of your PaaS-OE, and you log in by default with Tomcat unless you've changed the password, then you get into the Swagger documentation for the various endpoints. And for instance, I can now open one of the endpoints here, click on the tryout button, provides the name of an ABL application that is deployed at the pathway. If I wouldn't know that, there is also an endpoint that gives me the list of the deployed applications, and then I can execute that. And in the response, I see that I have an agent process running with this PID process ID. With that, I could then get further details of that agent, or I could even stop it. If I issue a delete request to the application name and the agent ID, I would be shutting down the agent in a controlled fashion. And that is what it means, that I can play with the endpoints, with the APIs. Here in the Swagger page, I get some description of what they're doing, and I can execute the request straight from here. The foundation for the Swagger page is the Swagger file. And if I go back into that page, we see at the top, there's an URL to that Swagger file. If I open that in the web browser, then we see a JSON document here with various sections, servers, tags, passes, components, and the info part with some descriptive text. And this is what we refer to as a Swagger file. Swagger files can exist in two formats: JSON, which is our preference, because we have ABL language support for JSON document. And I don't like YAML files, simply. YAML stands for yet another markup language, and it's a text file where indentation is describing the structure, and some symbols like minuses, etc. JSON just provides a clearer structure, if you ask me. But JSON and YAML can be converted back and forth. There are websites that do that, there are tools that do that. So what you can describe with YAML, you can describe with JSON, and the other way around. The section in the Swagger file, there's a metadata section which provides a description, a title, tags. A tag is a collection of endpoints grouped together. Servers are server addresses, IP addresses that the request would be issued to. Passes are then the URLs on those servers that we can access. There's a section for the component schema that provides description, like for instance for the pet, that a pet has an ID number, a name has a list of tags, a list of image URLs, etc. All that's described there, and the required authentication for a service. The Swagger IO website provides documentation for all of that. I must admit, it's not always easy to understand what they mean with that. So sometimes you may have to Google for some examples or additional description, but there's quite a lot of explanation there on the various elements there. On the schema, which for generating clients is quite important, we see their information about objects and their properties and the formats of properties. These properties go beyond just simple JSON properties. For instance, JSON just has one number type. But when you want to build a client or a service, it may be relevant to know whether it's an integer in 64 or a decimal type. And dates, for instance, JSON are always expressed as strings. So using the format property of a date property, we can describe that the string is actually a date in a certain date format, etc. Enums, we've seen enums in the pet store sample earlier, where we had the status, and it could be either available, pending, or sold. That is implemented by describing an enum of the status, and so on. There's validation. The Swagger document can provide documentation about required properties or optional properties, minimum maximum length for strings, minimum maximum values for integers, etc. So that if you're building a client, you can actually validate the data based on those specifications and don't have to make a request and get an error message back from the server saying, hey, this value is not in the range of expected values. Well, we already looked briefly at the OE manager OpenAPI specs. I'm going to skip over that. If you're editing Swagger files, there are different versions of tools. On the Swagger web page, there's the classic Swagger editor and the next generation or the next Swagger editor, which is still under development. And those are browser-based tools, where on the left-hand side you have the Swagger file. There you see the YAML variant with indentation and minuses to provide the structure. It could also be in JSON, and the Swagger editors in the browser also provides the option to convert YAML to JSON and vice versa. And on the right-hand side, you see the resulting Swagger page. So one option to build Swagger documents is to use these tools and edit it here manually. For service that we expose from the SmartComponent Lab, that's not necessary because we build these Swagger files for those services automatically on the fly. This is something I'm going to show later. That's a new editor. The new editor feels a bit more robust when it comes to large files. But I also had experiences where the editor simply stopped parsing the files. So it is still under development, but for the future, it looks pretty promising. And besides that, for various development environments, and I'm using VS Code here as example, mainly also because we at Consulting Work are using more and more VS Code as the editor for ABL code. So there are various plugins in VS Code that you can download that either provide editing support for Swagger files or provide a preview of a Swagger file. So on the left-hand side, I have an editor for Swagger files that provides validation support. And on the right-hand side, I have the preview plugin where you can immediately see how the Swagger file will look in the Swagger tooling. So when we look at building ABL clients, because while the demand to generate services based on the Swagger file is there, what we've experienced is that it's more frequent demand to build a client that accesses a REST service that's described via Swagger file. Unfortunately, on the Swagger editors, on the Swagger website, there's no option here to generate an ABL client. For various other programming languages, you can simply build a client here. It generates you classes, etc., that you can then just integrate into a .NET or a TypeScript project and are ready to go. For ABL, we don't have that. There's a lot in the ABL that provides the foundation for building Swagger or REST clients. In the box, one element there is the OpenEdge HTTP client, which we can use since, well, 11.5 technically, but I think preferably 11.7 because in 5 and 6 there were quite some bugs in there. From OpenEdge 12.8 for us, the HTTP client in the .NET Core framework becomes more and more relevant. The .NET Core HTTP client is just significantly faster when it comes to large documents. For smaller documents, it's neglectable, but when sending or receiving large documents and multi-part responses, etc. The .NET Core HTTP client is way faster. The OpenEdge HTTP client is available on Windows and Linux, and the .NET Core HTTP client starting 12.8 is also available on Linux and Windows, or accessible from OpenEdge on Windows and Linux. And then for handling the JSON documents, which are typically then the messages, input and output, there's a lot in the Progress JSON object model namespace to describe JSON objects, JSON arrays, etc. And temp tables and pro data sets can easily be exposed into JSON structures or from JSON structures. The challenge there is not so much the temp table to JSON. The challenge there is when we look at schemata of existing endpoints, and the Swagger pet store sample has one of these examples. We will recognize that the data structures which are expected there do not really match a temp table. So we see here the schema of the pet with a property ID, which is an int64 value, a name, which is a string. Then we have a category, which is an object, a nested object with ID and name. We have an array of photo URLs, and then an array of tags, and each tag has an ID and a name. And while I would like to have that in a single temp table record, with these two nested structures, their category and tags, that just doesn't fit well into relational structures. That is an object with a reference to a nested object that works much better as classes than as tables. So the ABL HTTP client is written in the ABL. The source code is available on the Progress GitHub page. And that is a client designed to use APIs, so RESTful APIs, provides classes for the client, the HTTP client, URIs, headers, cookies, the request response, etc. Supports the majority of the HTTP 1.1 spec, shipped with Progress in the OpenEdge.net.pl. .NET there has nothing to do with the .NET framework. That's just for OpenEdge networking. It is the only PL that Progress ships that's not automatically added to the pro path. So if you're using it, you need to add it to the pro path. It has an easy programming interface for the standards. It can become a little bit more complex with more complex scenarios. It is extendable. When you try to extend it, then it really becomes complicated. Then you need to understand the factories behind that and the registries for types, and then you can actually do a lot there. Platform portable, that means it runs on Windows and Linux. There are limitations. One is it's only for synchronous APIs or synchronous endpoints, and that means that when you make a request, the ABL execution waits there until a response comes back. And it doesn't support streaming protocols, which I think is not a big problem. I've never encountered the need in the ABL world, in the OpenEdge world, to do anything with streaming data via HTTP. Here's a sample procedure, and that's really the mother of all GET requests with the HTTP client. You build the client using the client library, or you first build a library using the client library builder. It uses the static builder pattern. Then you build a request. Here it's to bbc.com. Then you execute the request, and then you look at the response. For a put request would be to create new data on the service, or to update data. It's similar. You create the payload here, a JSON object. Then here I read from a temp table into the JSON object, but I could also populate properties manually. And then the put request is made to an URL with the JSON object as the request payload as the body. And then you can manipulate headers and so on, and then you do the execute that and get a response back. So JSON support in the ABL, there's a lot. The right JSONs of the temp tables and datasets were introduced in 10.2b. And later updated to include the JSON object and JSON arrays, output destinations. There's a CLS row and write JSON on a buffer. The progress.json.star classes were introduced in OpenAPI 11. And yeah, that's an OAPI, so you create new instance of those objects, or you use the object model parser to read a JSON document in a string or in a file into memory and parse it as an object. Well, a sample on that, but let's move on. JSON array. Look at that as a parser. The ability to manipulate JSON documents with the JSON object and the JSON array classes and access properties, etc., is quite nice. But as an application programmer, still you wouldn't like to fiddle around with JSON in your business logic or integration logic. For that purpose, we have since quite a while implemented a class that we call the consulting web JSON serializer. It's a base class that provides a very flexible JSON serialization and deserialization for ABL objects. That means that when we have a JSON structure that matches an ABL object, we can easily provide bidirectional transfer of the JSON object data into the ABL class and back. And that's actually the foundation for us to build ABL clients. We have in various samples for presentations like this released different versions of the JSON serializable class on GitHub. Not the most up-to-date class, but it works nicely as a foundation, and so feel free to use it. But now let's look at generation of stuff using a template engine. So when we look at Swagger documents, what can and should be generated out of those are the response and request parameter classes. So when we request all the pets based on the status, and we have the status as an enum that is described in the Swagger document, and we want to build an ABL enum out of that, and we have a class describing a pet with a nested class for the category and the tags, for instance. There's certain things in the Swagger document that require to generate interface types when we need to define properties that could be of either that or that type. Then we need to define the property as an interface, and the two classes that are the options need to implement that interface. The client can be generated out of the Swagger document and the service stubs. So when we look at the Swagger document for the OE manager, then you see on the right-hand side the section that describes one of the structures there. It's just a random pick there, the APSV transport properties. It's an object. It has properties: adapter enable of type string, allow runtime updates, collect metrics, enable request chunking, etc., etc. 9 character properties. Interesting enough, Progress has chosen to use strings for 0 and 1 for logical values, which I have my own opinion about, but I'm not gonna give that out public now. That translates into an ABL class like this. So it's in whatever package and class APSV transport properties that inherits from all JSON serializable and has ABL properties of the matching data types. Yeah, then the response there is something that Progress has not described in their official Swagger document. So we've created, in order to generate a client out of that, we've completed the Swagger document to include the description for the responses. Something I've never encountered before. All other APIs that we had to deal with so far were properly describing requests and responses. But here we see we have an object, or the response is an object with properties operation, outcome, result, error message, version string, and version number as string. And result is a reference to another type. So that's actually describing a nested object in there. And in ABL code, then we have this object there with the character properties and the result properties of the APSV transport properties type. So that is then what we use in the ABL to interact with the data, so that we don't always have to deal with JSON in our source code. And one particular benefit there is, for instance, that JSON is case sensitive. So if for whatever reason you would be lowercase in version string all through, so lowercase s in the middle, it would be expected that the receiving party would not be having access to the value of the version string, because yeah, in case sensitive, it's just not the same property name. That's now an example from a recent customer project. The requirement there was to integrate an ABL application with the CyberSource online payment system. CyberSource is a division of Visa. So like on my entry slides, the first thing that we did here is we looked for the Swagger file. The Swagger file that we found was actually Swagger 2.0, the previous standard 110,000 lines in the Swagger documentation. The Swagger document just specifies a massive number of endpoints and types. Their validation rules provide their mandatory fields, value ranges, enums, etc. My first task there was to convert the Swagger 2.0 document that they provide online into an OpenAPI 3.0, because our tooling expects OpenAPI 3.0. That can in theory be done using the Swagger editors on the Swagger website, but those failed, I assume, due to the size of the file. So I looked for other tooling to convert Swagger 2.0 into OpenAPI 3.0, and there's thousands of tools that do that. I just picked one, and that was able to convert the file. Then we looked at one of the APIs that we needed to access to make a payment, or to create a payment. So using our Swagger tooling, I then just chose the endpoint, navigated there, and said, now generate me all the types. And I was a little bit shocked by what our generator had to do. It had to generate 193 types. 193 ABL classes were created to describe the messages for the create payment body. That does not mean that in every simple use case we have to populate all those 93 classes with data. I think in the use case we had to deal with, we were populating 15 or so of those classes, but there are all these options. Yeah, those required us to generate this 193 types. So now, if we would like to code them manually, 193 classes based on Swagger document, how many interns would we need for that to build classes, interfaces, enums? Time for that would be the total effort divided by the number of interns multiplied by the frustration level. If we assume 10 minutes per class, and there are classes where I think it could be done a little bit faster, there were classes with more properties where it could be longer. we are looking at 32 hours. And even if I was just too negative and it would be 5 minutes in average, then we'd still be looking at over 16 hours to do that. And well, manual effort means mistakes will be made. What does it mean for testing? Who needs to code review that? In our products, the only code that is not necessarily reviewed is auto-generated code. All manual written code has to be reviewed. So what if the specification changes? And that's something that we see frequently in integration projects when we're not working against the standard API, but both sides in and out are working on the API during the project, then the specs may change. Data types of properties may change, names may change. Do we then have to do it all again? So this is something that you can really only manage at that scale when you have a code generator for those APIs. The code generator that we provide, that we use, is provided by OpenAPI out of the box. We have extended a little bit. Originally, this code generator was part of the RESTful tooling, the embedded speed script, which actually was designed to build HTML files with a mix of ABL code that's executed during the generation. But it's a very similar template structure than what Eclipse has in its jet templates, or Microsoft uses an ASP.NET active templates. When you look at those, that's the template for the parameter class. You recognize that there are carets and percentages that wrap ABL code. That is code that's being executed. Then the comment block there, that's text that's just going to be streamed into the output. The block level statement there too, and the usings there too. And some of those elements there provide control structures. If you look at the property definition, you see there's a loop over all the properties. And based on that, we put the define public property statements into our parameter types, and that's how we generate all that. We generate the validation there too, so based on max length or required attributes in the Swagger document. The input for the template is the portion of the Swagger file for the current schema element. We recursively generate the nested types. Schema references, you may have elements referencing the same schema portion using a $ref in the Swagger file. And in the end, the template file that we've seen there, when we generate ABL class out of that, the Swagger file will be, the template file will be converted into an ABL procedure. There's an include file that's being put into the template with some general definitions. Yeah, then the template is executed. Now let's look at the sample ABL client that was built that way. So for the pet store sample from Swagger, let's start by looking at the sample on the Swagger page. That's here. Let me first see whether we're lucky and we actually get a response. No, we get a 500. That's internal server error. It was working this morning, but later this afternoon it stopped working. I had the same situation yesterday. I don't know whether they currently have a problem that after a certain number of requests during a day, something blows up there, but it's not that relevant for the purpose of this presentation. Our tooling starts by a GUI application that allows us to explore the Swagger document. I see, for instance, that I have the pet find status endpoint with the get method. I could select that now, and when I've selected that, I can start generating either the client or the service stubs. And on the responses, we see the schema of the pet here as a reference. I can double-click this. No, double-click this one. to get to the reusable schema of the pet, where see the properties required is helpful for the validation. ID, name, category, and character array of photo URLs, and the tags and the status. We see the status is an enum with these 3 possible values. So I can, from here, the schema, and then click on generate the types. If I just want to generate the ABL parameter objects, I can do that now. I'm going to overwrite the code that I already have into the demo Swagger pet store client package with a log file. And when I do that, the log file pops up. And I see that it is writing the pet class with the pet status class, the tag, and the category class. And I can open those now in an editor. And we see we have the pet class with an ID in 64 property, name, category, photo URLs, etc. We have the pet status as the enum. Naming is sometimes the hardest part. When we look at this enum here, we only have the property name status, and then it is a string with an enum. A Swagger document could provide information how I should name my local class for it. Other Swagger documents do that. This one does not. So then what we do is, if it is a property status in a class called pet, then we say it is the pet status, and we camel case the names. So that is why the enum is called pet status like that. We have then the category class with an ID and a name, and the tag class with an ID and a name. And that describes the parameters to interact with the Swagger file. So then the next thing that I have generated already was then the client for selected methods. So I have a class called pet store client, which extends our generic REST client class, and the REST client class utilizes the ABL HTTP client. The class knows the URL of the API on the from the Swagger file, and then I do have a class that, or method that, returns an array of pets, so a list of pets. Input is the bearer token, because that is the authentication scheme that's described in the Swagger file, and the status as the input. And I think I have a second method here to get an individual pet by the ID. So that returns a single pet, and I put in the ID of the pet. So now we see here is generated from the data in the Swagger document. So we know the URLs for the addresses there. And with that, a client ABL program that would need to access that, all that has to do is create an instance of the pet store client class. Too big. And then call into the find pets by status class. I don't have to provide the OAuth2 token here. And I say, give me all the pets with the status pending. And then I could loop through the array of objects and get the response, but I expect that in this case, yeah, I'm getting the same internal server error from the backend. So As I was afraid of that, I did a screenshot earlier. So that was the output, just getting a list of pets. And yeah, and the important point here for the ABL programmer, nothing with REST or specifics of the API or whatsoever is here. No need to fiddle around with JSON documents is needed. We have an ABL class that provides a method, and whether that would be manually written and actually be returning the data from a database or a REST service somewhere on the internet is absolutely transparent. So we can just focus at consuming the data. Good. So another sample, which a colleague of mine sent me yesterday, because another customer said, hey, we need to talk to this REST point of the California Department of Tax and Fee Administration. What this API provides is it provides the ability to return a tax rate based on an address. Don't ask me which kind of taxes, but with that API, we can get either by latitude and longitude or by an address a tax rate. So we can look for an address in Sacramento, somewhere in California here, and we get the rate back. And they do have a customized Swagger page, so you probably recognize the description of the methods here. And we can try it out here, put in an address, and look up for the response. So I put in earlier the address of Apple, because that was the first thing that came into my mind when looking for an address in California. And we see that whatever the tax rate is, 9.0.09125% per mil, whatever, and gives some information about the confidence in the address lookup. Yeah, so, and also there we could just get hold of the Swagger document. It's much smaller. We see the responses reference to tax rate DTO. Typically, when I see this DTO as a suffix in the properties, that most of the time indicates that the backend is implemented in .NET, because that's the typical naming convention there for data transfer objects. Could also be used elsewhere, but most of the times I've seen that I was quite right with my guess that it was .NET based. Yeah, and also here we just generated the client so with the text info client class, we put in the input fields based on the Swagger document, set them into query parameters, and call in the text rate get rate by address endpoint, and then a client class would look like this and will return the same data. Looking at the time, I'm going to move on to the last bit of generating services. But all that we've done here is it's based on the HTTP client so far. So all this is supported tooling from 11.7 to 12.8, and works both on Windows and Linux. We are extending the generation of the client so that we can replace the engine that we can use on 12.8 and the .NET Core HTTP client when it's available. 12.8 generally supports .NET Core on Linux, but that doesn't automatically mean that every Linux server has .NET Core installed. And maybe not every Linux sysadmin wants to install .NET Core, so we're gonna keep the option to use the ABL HTTP client because, well, where we are, OpenEdge has to be already. So that's a no-brainer. So then now let's look at the servers. So let's assume I would have to build an OpenEdge backend for the pet store. So I would then be building SmartComponent Library based RESTful services. And using our tooling, we can generate an empty stub for the service based on the Swagger file. The foundation for that is just the fact that the schema types, so the classes that we generate for the pet and the category, etc., they can be used both to describe a client and a service. So if I now look at the service that we have here, then my pet store service is an ABL class. The class has one method. It's called the find pets by status. It gets a find pets by status request input object, and that input object has a property status which is of the type pet status. Then we annotate, and that's part of our framework, the class as a RESTful method. We give it the address stub. We need to provide here the full reference of the parameter class name, and that it's a get, and that the response to the request should be the return, which is here an array of pet objects. So and this is a portion which we can automatically generate. And then we need to start implementing that. And what I'm just doing here is now I'm going to create 3 pets. Gives them the IDs 1 to 3, a name and a category, and a tag queued, and put them into this list. So and this service does not need to be deployed on PaaSOE, because all we need is the R code to be available and a description file with the annotations, so that we can consume it at runtime. And then if I navigate to the Swagger page for my PaaSOE sample application here, I will find the pet store here. And I see that the request has the status as available, pending, or sold. And I can also execute the request from here. I should authenticate again. Authentication expired, so I'm gonna try it again, execute it, and I'm getting 3 queued animals. And in the documentation part, I do also see the schema, and I have the same schema here that is available in the pet store schema from Swagger. So the schema that we expose on the fly for the service that we created is basically a round trip to generate the same structure in a Swagger file. So now someone who has built a client for searching pets for the official Swagger demo would now be able, just by changing the endpoint URL, to use the same client application to talk against our backend. And that is also something that we fully support from OpenEdge 11.7 to 12.8. Works on Windows and Linux, works in Docker containers. Wherever you can run PaaSOE, you can use our RESTful services. Yeah, either generate them manually or use Swagger files to generate them. So the conclusion, well, Swagger is a pretty complete standard to describe HTTP-based APIs, typically JSON-based. And JSON has, if people are free in the choice of data format, JSON has pretty much replaced XML as a data type there. And REST has pretty much replaced SOAP. There's still SOAP servers around, but I think for everything new, it's REST and JSON. And when we have generator tooling for the clients and service, then the effort to build clients and services is significantly reduced. So looking at seconds instead of days. Every now and then, the services will need to be a little bit fine-tuned. That's also part of the truth. Some Swagger files are not as completely documented as others, but generally, there seems to be a very high discipline in using Swagger files because it provides so much added values. Good. With that, I'm at the end of my presentation. This was for now the last scheduled webinar this summer, but we are planning to have another webinar before the PAC Challenge conferences. So end of August, beginning of September. We are still thinking about which topic and when exactly, but we will announce that as soon as we've made a decision. Then you will find us at the PAC Challenge conferences both in Prague in September and in Boston end of September and beginning of October. And after the PAC Challenges, we will probably also continue with our webinar series. And with that, Lutz, have there been any questions?